Thomas Day, School of Life Sciences by Maui Herrera. Here we have some background information on Thomas Day and his levels of education. He received a PhD from Colorado State University in 1988 and also received his Bachelor's of Science with distinction in Colorado State University in 1981. He has a lot of professional experience. He is a current professor at the School of Life Sciences at Arizona State University, and he is a plant ecologist and received a lot of honors and awards from Colorado State University, the State University of New York, and the Associated Western Universities. Here is Thomas Day's research interest. His areas of expertise are climate change, deserts, biogeochemistry, ecology, ecosystems. Thomas Day is a plant ecologist who studies the causes that control a plant's performance, plant litter decay, and carbon recycling. Day's research examines how to visual and chemical properties of leaf litter control decay by substantial drivers such as sunlight and biotic drivers such as microbes. The journal that I decided to pick from was the Annual Review of Ecology and Systematics. The article title is Effects of UVB Radiation on Terrestrial and Aquatic Primary Producers, and the authors are Thomas A. Day and Patrick J. Neal. Here is the introduction of the article, and the hypothesis that I found was photosynthesis is more sensitive to UVB in plankton than in terrestrial plants, probably owing to less effective screening in phytoplankton. The prediction that I found in the article was that productivity of terrestrial plants is usually unaffected by enhanced UVB, although reduced growth has been observed and may increase in the magnitude over successive years. The background information that I found in the article was that our understanding of the importance of enhanced UVB levels on the dominant producers has grown immensely over the past 20 years, but by how? Experimental UVB exposure mimic ozone depletion has been changed. Here are the methods that I found, and with an aim to improve realism of UV experiments and facilitate a synthesis of findings, we make the following recommendations. To express doses using several published BWFSs is recommended. In the outdoor enhancement studies, in the absence of modulated system, use a stepwise approach and switch lamps over a overcast of days. Acknowledge using radiative transfer models to estimate social spectral iridescence. And initiation studies include treatment that provided relatively small reductions of the ambient UVB, and acknowledge how the temporal realism of UV manipulations may be improved, for example, by compensating for several seasonal trends in the ozone levels of UV iridescence. And this was the methods that I found in the article. And the results were that the stratospheric ozone depletion by anthropogenic gases has led to increases in levels of solar UVB reaching to the Earth's surface. The aquatic productivity is often compromised by short-term exposure to ambient as well as enhanced UVB. However, longer-term assessments of UVB effects on aquatic producers are complicated because of the difficulties involved in accounting for horizontal and vertical mixing and nonlinear nature responses. And this was the results that I found in the article. And so I was left with the discussion that Thomas Day's hypothesis is supported and by the data that I found in the article, and because the aquatic productivity is often compromised by short-term exposures to ambient as well as enhanced UVB, the implication is to test whether photosynthesis is more sensitive to UVB in phytoplankton than in terrestrial plants, probably owing to less effective screening in phytoplankton. And so he has supported his claim with the evidence that he left in his article, and this was the following discussion to the article that was written by Thomas Day and Patrick J. Neal, and this is my PowerPoint on Thomas Day, a professor at ASU and the School of Life Sciences. And thank you. Have a good one.